Hi to everyone, this is your Sankarappa sir. In today's class, we discuss about the scattering parameters. The scattering parameters are to be represented by S. It is to be represented by S. Okay. So before going to the scattering parameter, first we discuss about the two-port network. Two-port network. So let me consider a two-port network device. It is a two-port network which has the input port and output port. Let it be, this is the port 1 and this is to be the port 2. It is a two-port network. So let me consider the voltage V1 and V2. And the passing current through this is I1 and through this is I2. I1 and I2. So it is I1. Due to the voltage V2, it is I2. And this one is I2. It is a low frequency concept. Two-port network is a low frequency concept. By using this, we can find the voltage and currents by using the parameters like Z parameters, Y parameters, H parameters and ABCD parameters. These voltage and currents are to be interlinked with the terms of Z, Y, H and ABCD parameters. For example, V equal to IZ, ZI and V1 equal to I1, Z1, I2, Z2 and etc. Suppose if it is to be the two-port network device, it is a two-port network device and these voltage and currents are to be interlinked with impedance Z as V1, V2 will be equal to Z11, Z12, Z21, Z22 into I1, I2. So in the similar way, we can represent the other parameters also like Y parameters, H parameters and ABCD parameters. So in this V1 can be expressed as Z11 into I1 plus Z12 into I2. So this V1 equal to Z11 into I1 plus Z12 into I2 and similarly V2 can be expressed as it is Z21 into I1 plus Z22 into I2. By solving these equations, you can determine the values of the voltages and currents. So it is the low frequency concepts. Whereas to determine the scattering parameters, we can use the high frequency. That too in terms of the gigahertz range of the frequency for a microwave device. These scattering parameters can be derived in the similar way of two-port network device by applying the powers instead of the voltage and currents. To determine the values of the scattering parameters, we can apply the powers. There also input power and output power. Instead of determining the input power and output power, we can determine their ratios. Okay. These scattering parameters can be derived or can be determined by using a four-port network device. Similar to the two-port network device, we can design a four-port network device. This is similar to the traffic junction. It is similar to the traffic junction. Like all the vehicles are to be coming in the different ways. They are to be meeting at point and they goes out with the different paths. So you can show it schematically and then we can move to how to derive the scattering parameters of a microwave junction. Okay, is it clear? So it is the four-port microwave junction device. So let me consider it as a port 1. It is the port 1 and this is to be the port 2 and this one is port 3 and this one is port 4. Port 1, port 2, port 3 and port 4. So it contains microwave source and the microwave loads are to be connected with the microwave junction. For example, port 1 is to be connected with the microwave source port 1 is to be connected with microwave source. This signal is to be given to the microwave junction. This may pass out through the port 2 or port 3 or through the port 4. That means one signal may come out through the port 2, port 3 or port 4. It may also possible to come out through the port 1 itself, because if all the ports are to be perfectly matched with the junction, then whatever the power is to be coming to that port, that will completely absorbed by that port. If there is a mismatching between the junction, then there is a possibility of reflection in that particular port. Okay, now you can see through the port 1 we are applying the microwave source or the microwave signal. It may come out through the port 2 or through the port 3 or through the port 4. Remaining power, whatever the remaining power is there, that may come out through the port 1. That means when the signal is to be given at one port, we are getting 4 outputs. In the similar way, if we apply the power at port 2, input at power port 2, we can get the power may come out through the port 3, or it may come out through the port 4, or it may come out through the port 3, or also possible to come out through the port 2 itself. That means when the power is to be given through the second port, it may come out through all the 4 ports. There is possibility of another 4 outputs. Similarly through the third port and through the fourth port also. Therefore, when the power is to be given through all the 4 ports, we can get 16 combinations of outputs. 16 combinations of outputs. These outputs can be determined by using the parameters like S parameters, scattering parameters. That you can see how it is to be distributed when power is to be given at one port, when it is to be transferred and it will become out through the other port. Now we can see the input output relations are to be represented in the form of the matrix. That matrix is called as the scattering matrix, and the parameters which are contains that matrix are called as the scattering parameters or S parameters. This scattering matrix is a square matrix. Their power relations or the input output relations are to be represented in the form of the S parameters. Those parameters are called as the scattering coefficients. The scattering coefficients which are to represent the form of the matrix is called as the scattering matrix. It is a square matrix. Okay. Now, those relations can be obtained by using this schematic diagram. Let you consider it is a source, input line, input port. It is to be connected to the ith line. It has the n number of lines. First line, second line, third line, fourth line, etc. Nth line, n number of lines. And they are to be connected with load impedance. ZL is the load impedance, Z0 is the characteristic impedance. In the first case, let me consider the first line is not to be terminated with the characteristic impedance. First line is not to be terminated with characteristic impedance, and the other lines are to be connected with the load impedance will be equal to the characteristic impedance. First line is terminated other than the characteristic impedance, and the second line onwards, the lines are to be connected with characteristic impedance, with equivalent to the characteristic impedance. When the input is to be applied through the source line, it will splits between all the lines. It may come out through the first line, or through the second line, or through the third line, fourth line, and etc. Nth line. Second line to the nth line, they are to be perfectly matched. That means whatever the signal is passing out through that second to nth line, they are to be completely absorbed. Because there is a perfect matching between the load line and characteristic impedance, load impedance and characteristic impedance. Where the first line is not to be terminated properly, Hence there is a reflected wave. If A1 be the input, B1 be the output, this B1 can be interrelated with the input by using this scattering parameter as B1 equal to SI1 into A1. So first line is not to be terminated properly. It is an improper termination, and the remaining all the lines are to be perfectly matched with the junction. Therefore, second line to the nth line, the signals are to be completely observed, no output, whereas the first line is improper termination. Due to that, an output will comes out. Through that, a reflected wave will comes out. That reflected wave can be interrelated with the input of A1 as B1 equal to SI1 into A1. Okay. Now in the second case, let me consider all the lines are to be improper termination. All the lines are having the improper termination. ZL is not equal to Z0, ZL is not equal to Z0, ZL is not equal to Z0, and nth line also ZL is not equal to Z0. Now, the signal will split up between all the lines. When passes through the first line, second line, third line, there is a possibility of reflected because there is improper termination. Due to that, this outputs may be expressed as equation as BA equal to S I1 into A1 plus S I2 into A2 plus S I3 into A3 plus etc. plus S IN into AN. Okay. Once again, in the second case, we are assuming all the lines having the improper termination. Load impedance is not equal to the characteristic impedance. That means ZL is not equal to 0, ZL is not equal to 0, and etc. ZL is not equal to 0. When the input A is to be given, this will split up between all the lines as A1, A2, A3, A4, etc. AN. There is improper termination. Due to that, a reflection may take place. That may be B1, B2, B3, etc. Bn. These B's outputs are reflected waves can be interrelated with the inputs by using the S coefficients or the S parameters as BA equal to SI1 into A1 plus SI2 into A2 plus SI3 into A3 plus etc. plus SIN into AN plus SIN into AN. So this I is represented with the ith line, may be varying from 1 to n, where I equal to 1 to n. Now by substituting I equal to 1, 2, 3, etc. n, we can find the values of B1, B2, B3, etc. Bn, and similarly the S values and the A values, scattering parameter values and the A values. Now we will substitute I equal to 1, 2, 3, 4, 5, etc. n to obtain the matrix and the interrelation between the input and the output by using the scattering matrix and the scattering coefficients. Okay. Now we can see by giving the values of I with 1, 2, 3, etc. n, we can get the different values of the equation by substituting I equal to 1. This is B1 equal to S11 into A1 plus S12 into A2 plus S13 into A3 plus etc. plus S1 into A. And then by substituting I equal to 2, it is B2 equal to, it is S21 into A1 plus S22 into A2 plus S23 into A3 plus etc. plus S2n into AN. And similarly B3 equal to S31 into A1 plus S32 into A2 plus S33 into A3 plus etc. S3n into AN and etc. Bn equal to this is Sn1 into A1 plus Sn2 into A2 plus Sn3 into A3 plus etc. plus Snn into An. Okay. Now these B1, B2, B3, S and A1, A2, A3, etc. they are to be represented in the form of the matrix, column matrix. Okay. Now these waves can be related by the matrix, can be written as matrix B1, B2, B3, etc. Bn will be equal to, it is S11, S12, S13, etc. S1n, S21, S22, S23, etc. S2n, S31, S32, S33, etc. S3n, and etc. SN1, SN2, SN3, etc. SN into A1, A2, A3, etc. A. Okay, where B is output, A is the input, and S is the scattering matrix. So it is the column matrix of the output column matrix, and this is the column matrix of input, and this one is the called as the scattering matrix. Column scattering matrix. So the scattering matrix is a square matrix. The order of the scattering matrix is n by n. So these individual elements or the individual coefficients are called as scattering coefficients or the scattering parameters. So it is the interrelation between the input and the output. So if you observe, it is similar to the two-port network device, whereas the two-port network can handle only the voltage and currents. They are to be use the relation between the voltage and currents by using the parameters of Z, Y, H and ABCD parameters. Whereas the scattering parameters are to be represented with a high frequency, particularly for a microwave. It is in terms of the gigahertz range of the frequency. They are to be interlinked with output power, input power, interrelated with scattering parameters. So it's about the scattering matrix and the scattering parameters, scattering coefficients. Okay. Now it is a matrix. It has some property. These properties are similar to the mathematical properties. So in the case of matrix, we can say that it is a symmetric matrix, it is a square matrix, and etc. So now we can see what are the properties of this S matrix. So scattering parameters are the properties of the S matrix. Now the properties of S matrix. So first one, S matrix is a square matrix. It is a square matrix. S is a square matrix. Second one, this scattering matrix, S matrix, is a symmetric matrix. It has a symmetric property. That is Sij equal to Sji. That means S12 equal to S21, S13 equal to S31, S23 equal to S32, or S24 equal to S42, and etc. Next, it has the unitary property. S is a unitary property. S has followed the unitary property. That means S into S complex conjugate will be equal to I. I is the unitary matrix. It may be 1 0 0 0 1 0 0 0 1 0 0 0 1 0 0 0. All the diagonal coefficients becomes to be the 1, remaining all the elements are to be 0 is the unitary matrix, identity matrix. Okay. Next, for example, in the previous representation schematic diagram, we are represented with nth line or n lines of transmission lines. If any line is to be moved to a distance of electrical distance of beta L, let it be beta k into Lk. That means kth line, that particular line is to be moved to a distance of electrical distance of beta k into Lk. Then all the coefficients which are contained by that particular line is multiplied by the factor of e power minus j beta L, beta k into L. Those factors are to be multiplied with the factor of e power minus j beta L or beta k into Lk. Now, one more. A sigma summation of, let us consider Sij and Sjk. These are the two lines. Summation of Sij into Sij complex conjugate. Sij into Sij into Sjk complex conjugate will be equal to 0. Where Ijk are varying from 1 to n. Summation of the or sigma summation of Sij into Sjk complex conjugate will be equal to 0. So these are the properties of the S matrix. Okay. Now by using this S parameters, we can have the microwave T junctions. The microwave T junctions may be the different types. They may be the H plane T junction, E plane T junction, EH plane T junction, or hybrid T junction, or magic T junction. And one more, we can move to the another one as a directional coupler. These directional couplers may be different types, among that two-hole direction coupler and single hole or the Bethe hole directional coupler. So these we can study about by using this S parameter. Some more like isolator, circulator also we can study about study by using this S parameters. Okay. Thank you all for seeing my video and subscribe my channel for more and more videos. Like my videos, share my videos for the number of videos. My videos will be definitely helpful for the number of students and it will be useful for your competitive exams or to your university exams or to your any type of the exams. Those for reading about the microwave theory or the microwave engineering. Okay. Thank you all. For once again I am requesting you all subscribe, share and like my video. Thank you.